vibration will produce a full wave. So there are 10 waves produced per second. So the actual frequency is 10 Hertz. But if now the source is moving towards the listener, well, I said here the source will be spread out in a circle. The waves produced by the source will be spread out in a circle of radius V. So if this is the circle of radius V, all the waves produced in 1 second will be in that circle. Is that right? That's the meaning of this sentence. Now, but since in 1 second the source itself has moved a distance Vs towards the listener, these waves are now compressed in a region V minus Vs. I hope you understand that statement. Well, that is a very important statement, and I want you to understand that very well. All right. Now, suppose we said V is the speed of sound. That means in 1 second, you see, all the waves produced in 1 second. Suppose these are all the waves produced in 1 second. If the source is not moving, all those waves produced in 1 second are spread in a region V, because V means so many meters per second in 1 second. So all the waves produced by the source are spread out in a distance V if the source is not moving. There you are. But when the source is moving to the right with a speed V, all those waves are now compressed in a region V minus Vs. You understand that, don't you? There you are. These waves are now compressed in a region V minus Vs. Now this is V, this is V minus Vs. So all these waves which were originally spread out in a distance V are all now compressed in a distance V minus Vs. Now, if F0 is the actual frequency of the source, there will be F0 waves produced in 1 second. And all these F0 waves, now here are the F0 waves. All these F0 waves are now spread in a region or in a distance V minus Vs. And therefore, what is the apparent wavelength of each wave? The wavelength of each wave reaching the listener now will be these many waves, F0 waves, spread in a length V minus V0. That means the length of each wave reaching the listener now will be this distance divided by the number of waves. If lambda prime is the wavelength that reaches the listener, that lambda prime will be this distance divided by that number of waves, which is F0. F0 is the actual frequency of the source. And look at the way a mathematical manipulation I did here. I factored out a V from here. Now, is it possible for me to factor out a V from these two terms? Yes. But all I did is, watch what I did here. I just multiplied this Vs by V and divided it by V. So, I just multiplied by V and divided by V, this term. And that way I created a V that is common factor. I took it out. Remaining here will be 1 minus what remains here is Vs divided by V. So, this V minus Vs is the same as V times 1 minus Vs divided by V over F0. And that is the apparent wavelength that is reaching this listener. Okay. There you are. Now, if F prime is the frequency as the listener hears, if F prime is the frequency that the listener hears, what will be F prime? F prime will be V divided by lambda prime. And the lambda prime is this. So let's replace this lambda prime by this quantity. That would be V divided by lambda prime is V times 1 minus Vs over V over F0. And you can see why I wrote it like this. You can see that V and V will now cancel. This F0 will now go to the numerator. And that's equal to F0 divided by 1 minus Vs divided by V. What does Vs stand for? The velocity of the source, and V is the speed of sound. This is the frequency that is actually heard by that listener, or we call it the apparent frequency. Why do we call it the apparent frequency? Because this is not the actual frequency of the ambulance siren. It is the frequency as is experienced by the listener. You see the difference between actual frequency and the apparent frequency. The frequency as is heard by the listener, which we call the pitch of the sound he hears. The pitch of the sound he hears is higher than the actual pitch. Alright? And we can simplify it as taking V as the common denominator, F0 over V minus V, Vs over V, and we can write it if we want like this. F prime equal to, this V will go up. It will then become V over V minus Vs multiplied by F0. But I prefer just to hang on to this equation. F prime equal to V F0 over 1 minus Vs over V. Now, this is the case where the source is moving towards the listener. Alright, the second case, the source moving away from the listener. What happens when the source moves away from the listener? What is the situation now? Now tell me, what difference will there be when the source is moving away from the listener? Well, when the source is moving away from the listener, the waves in front of the listener get stretched. In this case, the waves are stretched out in a region V plus Vs. You see, because there is more space for the waves because the source is moved away. And the apparent frequency can now be written as, you see, if you go back and look at the old equation, the denominator was 1 minus Vs over V. So the only difference here is that in this case the denominator will be 1 plus Vs over V. The apparent frequency as is heard by the listener now will be F prime equal to F0 divided by 1 plus Vs over V. That will be, again I can take V as the common denominator. This will become V plus Vs over V, and the V will go up. It will become V over V plus Vs times F0. Now I'm going to give you a couple more equations. We are not going to bother about deriving it. Listener moving towards the source. Now will that be different? This time the ambulance is going to stay in one place and the listener is going to move towards it. What will be the apparent frequency? the apparent frequency of the sound is given by f prime equal to f0 times 1 plus Vs over V. Alright? Keep track of these equations. It'll be useful when we need to solve problems. Now, listener moving away from the source. What happens when the listener moves away from the source? The apparent frequency will be given by, the only difference is, this plus will become minus. So f prime is f0 times 1 minus Vs over V. We have 4 formulae. What is the first one? The apparent frequency that a listener hears when a source moves towards the listener, and that apparent frequency will be f0 divided by 1 minus, not this one, for that this plus will be minus, 1 minus Vs over V. That will be the apparent frequency as the listener hears it. Now, this is the apparent frequency as the listener hears it for the source moving away from the listener. And this is the apparent frequency when a listener moves towards the stationary source. And this is the apparent frequency when the listener moves away from a stationary source. Alright, so keep track of these 4 formulae. Write them down so that you become familiar with it. I don't want you to learn them by heart, because you know you can keep all these formulae with you when you solve problems. Alright, let's